It's requested everybody to please seated. I kindly request everyone to have your seats as soon as possible.
I request everyone to please be seated.
Welcome back after lunch. Once again, we are delighted to have Suraj SD sir with us to address the gathering. We are truly pleased to welcome you, sir, for another couple of hours of valuable insights. So, so please embrace the stage.
All right, so you have to listen to me again. That's good, that's bad, it's very bad. It's quite unfortunate that the other faculty or the speaker who's supposed to travel have some delays to travel. So I'm given an opportunity to speak for another 1 hour and make you all sleep. Yeah. So that you can get a good sleep and you had a good lunch. What do you guys think we should speak? I'm glad nobody is sitting in those seats anymore. Everybody is sitting in the front rows. Good. All right. So, would you guys like to learn technical things, non-technical things? Or nothing? Okay. So, it's afternoon. I know it's difficult for all of you to definitely sit and listen. So let me just make the session quite lighter. Today morning I told you about the story of Aether. I just thought to start the session with a couple of videos. Okay. The intention is that I want it to be motivating for you so that you see how things got started for Aether or anyone and where they are today. The audio, guys. Good. small journey that you see, you know, how is what started? Yeah. So it was in a small college project. You know how big the Aether is today? About 12,000 crores. The total company valuation is about 12,000 crores, nearly, oddly. And they were also in an IPO, initial public offerings, I think recently, in listing of National Stock Exchange. And this is one of their video of test facility.
An ether. What makes an ether an ether? This is the Juggernaut, Aether's engineering playground. It's a tough, rugged battleground. Inside this 38,692 square feet of brutal testing madness, precision meets innovation. 1 lakh kilometers? We crushed that in just 15 days. From component level to system, if there's a way to test it, we've probably got it covered. Why an Aether, you ask? Here, every Aether goes through 350 plus brutal tests before it can even earn its name. Every strain, every vibration, every sign of weakness is tracked, analyzed, and eliminated. Ah, batteries, the heart of the scooter. We drown them, bake them, and drop them into submission. Abuse tests, our specialty. Software validation, flawless. Oh, but we're not done here yet. Finally a shower after a long, hard day. Just like you, the scooter comes out looking sharper, cleaner, and ready for whatever is next. See you on the road.
So that's just one of the example of, if you see, it was a college project. It was a college project, yeah. Now you saw the lab. That is one among the world's best labs that is present in India for testing and validation of EVs, right? So what it gives you a perception, like when I was telling you the dyno, when we were showing the dyno lab, all the other labs, anybody can get into testing and validation. What is testing and validation? So the product development journey, if you take it through, so where does it start? What is the first part of the product development? It's a concept, it's a idea. Then, what is the next step? Let's say you get an idea of your project. What do? You research about it, you get a clarity of how to do it. It's basically the planning part of it. Then next, what's the next step? You would do a basic level of prototype, right? It is called as proto samples. Then what is next? During the cycle of prototyping, that is called as a design and development, okay? That is where a lot of research, a lot of engineering, a lot of time that is being spent, right? That is what is called as R&D, research and development. Then once the research and development phase goes through, we will build a first prototype. Usually in the industry, the first prototype is called as A sample. What is it called as? A, letter A sample, okay? We build about 10 of them. We build about 10 units. Then we do, what we do? We will do testing, correct? Then what testing will give you as an input? It will tell you these are the failures, it is not working like this, it is supposed to work like this. vibration test, temperature test, functionality test, lot of other tests are there, right? What tests will give you feedback? What again R&D team will do? They will reiterate the product, right? Once they reiterate the product, again they will build a next sample. That next sample is called as B sample, okay? They make about 25 units of those samples or 50, depending upon how many you want to do. Again, what happens? The testing journey comes in, right? This time the tests are very extensive. It's long duration, okay? When we say the product is at a B sample stage, it means the product is almost 90% ready, okay? Then we go to we do more number of tests, like on-road test, all the different type of tests, and there is something called regulatory compliance test. Okay, what is it called? Regulatory compliance test. It is called as homologation. When you buy a bike or a car, would you mind to reduce the volume a little bit? It's too much echoing, I think. So, if you buy a bike or a car, you will get a certificate from ARAI. Your mileage is X. Would you get it? It is there, right? Who certifies it? ARAI, Automotive Research Association of India, which certify. It is a certifying body in India. Also, there is one more certifying body called ICAT. ICAT. You can make a note of it because there are internships, there are jobs that you may be able to apply for. Okay, so they will have some standards in the country. For the specific country, they have set of standards. So you have to pass those standards. When you pass those standards, that means your vehicle is almost ready for being sold. Then what company do? They do a C sample. During the C sample, they make close about 250 vehicles, 200 vehicles, depending upon the capacity. Okay, it is the first batch production. It is not like when you make something you can produce. There are a lot of challenges which comes in production. Imagine you're developing a bike. At the last, there is one guy who is not tightening the screws properly. Which is the screws or bolts for the wheels. What will happen? You will see an accident on the road, right? Very simplest, the guy who just turns the bolt can make a product go bad. Some guy who connects the connector, if he makes any mistake in connecting the connector wrong, the product will fail or even catch a fire also. So you need to iron out all of this. You need to do a process optimization. So they do a process optimization with about 250 vehicles of production. And that is your first batch of production. Okay? And then the manufacturing and all of these things happen. And there is again a continuous testing that happens over the number of days. So you understand what is testing means now? Automotive testing is one of the most expensive. It consumes more than about 50% plus of the product development journey. That means how many jobs are available in testing? There are many job opportunities in testing and validation. Okay, that is the one job role. So what it can be for a motor testing, for a cell testing, for the battery testing, for the BMS testing, for the motor controller testing, for the charger testing, for the DC-DC converter testing, for the HMI testing, for the wiring harness testing. What else is there? Suspension testing, steering system testing. Go on, what else? Chassis testing. Many things, right? Even the connector, the charging connector that you get, how many times you will put the connector, you remove the connector? If you buy a car, how many times you do that? 10,000 times maybe, right? So somebody you have to give you a warranty that it works okay for 10,000 number of times. So all of this efforts goes in testing and validation. Okay, at a component level and also at a complete system level, subsystem level, and a system level at a vehicle. Okay, and that's why there are plenty of opportunities for test engineers. So somebody was asking maybe in the morning session, what should we teach students, or what should we tell the students to learn? So what you should learn if you want to be a test engineer? Sorry? Yeah? So you should be very thorough with how the component works. So first you should know how to write a speed torque characteristics of a motor. Right? So a lot of basic things are required, and you should have a hands-on experience with working of components in place. Alright? So that is a job of a testing and validation. What else the other kind of jobs are there? Which we spoke about, research and development, right? The product development or research and development. So what usually happens in that research and development? Any quick example? Okay. Let's take a motor controller. So motor controller consists of what? Okay. A lot of power electronics, right? So if you have to work on power electronics, what you should know? You should know power electronics, right? Then to do power electronics, how people will do first? First you should have a subjective knowledge of components, then you will do simulations, then you do design and development of PCB boards, schematics, PCB boards, then manufacturing of PCB, and then finally comes to testing and validation of power electronics in place, right? Then on the other side, this is on power electronics. If you want to control the motor, you should have a knowledge of motor and its characteristic behavior. So that is what is differentiating. If you want to work in R&D, it is very subjective, it is very intensive, okay? That is what differentiates between somebody works in research and development, somebody works in testing. Testing is slightly much comparatively easier than compared to research and development. So if you want to get into research and development, you should be a kind of an SME. What is SME? Subject matter expert. Okay, and that's the broad idea of two differentiations. And then the last thing is, when you sell a product to someone, what happens? What do you expect after selling the product? Service, right? So there are also engineers who works in service. It's not like repairing a bike, opening the bolt or nut, but diagnosing the problems, identifying the trouble causes, right? What if the company keeps replacing their batteries? What will happen? One day the company will close, that's all, right? So somebody need to understand the root cause, why it has failed, what has happened, what is the reason behind it. Okay, that's on the after sales, service, support, and kind of a job roles. There are very miniature job roles which are not very large in scale, which is called cost engineering. Have you studied cost engineering? When Tata Motors want to manufacture 10 lakh cars, 1 rupee for each car saves 10 lakh rupees. If they save 100 rupees on each car, that's a lot of money. Okay, there are facilities in every company. If it's Tata Motors or TVS or Mahindra or anywhere, you know what do they do? If Tata Motors launches one car, they will buy that car. They will tear down every single paper of the vehicle also. Like even the smallest sticker that is put on anywhere, they will take it, they will check what is the price of this component. Because if somebody has developed a vehicle at 5 lakhs, I am making a vehicle at 7 lakhs, will you buy? Obviously you will not buy, right? This is called benchmarking and test. It is called benchmarking and cost engineering. It means you will buy a product from the market, you will do complete tear down. Every part you will disassemble, you will check the weight, you will check the size, you will check the complexity, manufacturing engineering, materials, thickness, every single thing, and then say, oh, this is the cost of the product, right? That is called benchmarking and cost engineering. There are some more teams called VAV, value added value engineering. Okay, value added value engineering. Imagine 10 years before you designed one transmission system. Okay, how I can reduce the complexity of the transmission system, which was made at 5,000 rupees, I can make it at 3,000 rupees. Possible? Because in 10 years, a lot of manufacturing technology has evolved, a lot of engineering has evolved, right? I can make, maybe there are 5 parts, I can make 5 parts into 3 parts. What happened? Imagine in the production line, there was a one step to assemble one part, there is another step to assemble one more part, there is another step to assemble one more part. So there were 5 steps. Each steps take 3 seconds, 5 seconds. If you remove 3 parts, what will happen? You almost save 15 seconds in the production line, right? That 15 seconds for a one car, for 10 lakh cars, it's damn significant for a company, right? The people work like this on a value added value engineering. So they will be able to optimize, because you know, every 2 minutes or 3 minutes, one vehicle comes out in the production plant. Every 2 or 3 minutes, a vehicle comes out. If you go to a Tata Motors plants, Tata Ace, every 2.5 minutes, one vehicle comes out. Imagine you are able to save 2 seconds, or 3 seconds, or 4 seconds, or 5 seconds. For each vehicle, they make about 2,000 vehicles in a day. So a lot of cost savings, right? So that's how broadly, I think few roles that I was able to remember to tell it to you. Because after your graduation, if you were to apply for a job, what do you will apply it as? Electrical engineer? No, right? You cannot apply just like that. So you need to apply for kind of a specific job role. So these are the job roles. Can somebody repeat what are those job roles? Forgot already? No, don't start from the top. Go from the first. Testing and validation. Then research and development. Then after sales and not sales, service engineering, then cost engineering, benchmarking, then VAV. Like that, there are many other roles. Okay, hundreds of roles are there, but broadly in a category of large scale hiring, this is what happens. Cool. Any questions about that thing? Nothing. Okay. If no questions, I'll go back to presentations. Any questions? Enough. I've been mandated to do it till 4:30. So, any other questions? Okay.
It's kind of a question that I was just researching. I found out that the amount of application EV has on in our daily life, it is more of its application in our space programs, like the further colonization of other planets, or in the space programs where robots are being introduced. EV plays a significant role in that also. But in a broad prospect, we don't see into that. We just stay in the real life. That is also real life, but in the common applications. But I believe that beyond this, EVs can have a large field to cover.
I do not know if I can answer to that question right now, but there may be something that would have been there possibly. I do not know to fully answer the question. Okay, so in the morning we started with these presentations. Is it visible? What was the first question I asked? What was the first question I asked you in the morning? Forgot? So list the components of EV, right? So are you able to see? Should I zoom? Maybe start with this one. We have a transmission. Yep. Then we have a motor. We have an inverter. We have an onboard charger. You can just pick the. So we have multiple parts. We have transmission. We have motor. We have inverter, onboard charger, DC-DC converter. We have BMS. We have a complete battery pack. We also have a component called battery heater. Okay. We have a AC compressor. Then we have VCU. Mostly, that's what constitutes the components. I think this is also continuation of that. Okay. So what do you see in this diagram? We have variety of motors, right? We have motors like this. What do we call for this type of motors? We call it as hub motors, right? These are called mid-drive motors. All right. What is the need of transmission in any vehicles? Okay. All right. When you put a gear in the vehicle, what really happens? How many of you drive bike? The geared bike? Okay. How many of you drive scooter? Most of you, right? Is there a transmission in the scooter? How many of you say yes? Is there a transmission in the scooter? How many of you say yes? Okay. Is there no transmission in the scooter? Guys, I know it is afternoon. You should not make me sleep. How many of you say, is there a transmission inside the scooter? Yes or no? How many say yes? Okay. I have to come that side and ask so that you guys will raise your hands. How many of you say there is no transmission in the scooter? Rest? None of the above. Or all the above. There is a transmission in the scooter also. Okay? It is called as CVT, continuously variable transmission. In the bikes, we have manual transmission. Okay? How many of you got the papers back? Or you left the papers in the home? Okay. I will ask you a question. Imagine you are starting your bike. Okay? You want to come to college, you ask your dad, he's in a happy mood, he gives you a bike to go to college that day. Imagine you're starting the bike, then you're coming on the way, there is a traffic light, you stop, then you come again, you want to overtake someone, then somehow you go all the way and then come to college, right? If you draw, what is the torque required by the, or torque required at the wheel? Can you draw a diagram? Your y-axis is torque, your x-axis is time or distance. Anything is okay. Can you tell me how it looks like? Just try to draw it. Sorry, sleeping, disturbing. If the vehicle starts, right, what is x-axis? Time or distance. Your y-axis is torque, right? Torque at the wheel. You will all know this by the virtue of your childhood. But I'm asking you to translate that into the graph. Okay. How many of you done? I got 1, 2, 3, 4 answers. 2 of them are correct. Anybody else? Like at least just draw it for first 10 meters. What torque do you require for first 10 meters? Done? Okay. Now go back to the very old school days. Okay? I don't know how many of you have known Atlas bike, Atlas cycle. Okay? You know what you used to do? Put the stand on and rotate the chain. When you want to rotate in the beginning, was the torque required more or less? High, right? When you start to rotate gradually, after some time, what will happen? The torque required is less. So, the torque required in the beginning is more, correct? It's the same thing. When you're pushing an object, to move it slightly, it takes a lot of torque. After you move it, you will be able to push it more easily. Why? Because the one is the friction, in is the momentum, right? The now object has carried a momentum. If you put that graph, how many of you got it? Okay. Can you compare that graph with a motor graph? What is the similarity? If you want to move the vehicle, you need a high torque. And motor also produces a high torque. That is why motor is most ideal for tractive applications. Now, can you write the diagram of the engine's torque versus speed characteristics? I hope you all have phones. Yeah, can you open your phones and then just check ideal speed torque characteristics of a IC engine? Tell me how it looks like. Okay, if you see a graph here, this is how the speed torque characteristics of IC engine is. Now, can you draw all the three graphs on the same graph? Speed torque characteristics of motor, speed torque characteristics of vehicle, speed torque characteristics of IC engine. So both of them will come like this, right? The engine will come like this. Remember? Clear? Now, if I open the next tab, tell me what is this graph? Sorry? That is the gears. When you, the engine torque, you know, engine is not producing enough torque in the beginning. Without producing more torque, can the vehicle move? No, it cannot move. That is why what we use? We use a gearbox in IC engine. Do you think now the gearbox is required in EV? Is the gearbox required in EV? Do you think the hub motors have a gearbox? They may. But do we have any EV? Have you ever seen any EV with transmission? Have you? Yes or no? Is there any EV with a gearbox? 1, 2, 3, 4. Why? Because the motor itself has a very high amount of torque. The motor's torque is almost equivalent to the vehicle torque demands. Okay? That is why IC motors are more suitable for a tractive applications. Okay? And that is why, if I go back to my presentation, if you see the final drive, differential, that's all. It is more than sufficient. Like, whatever the big gearbox is to come, now it will come in this size. Do you think there was ever any possibility to put an engine inside the wheel? Have you seen an electric vehicle with a hub motor? It is there. Have you seen any engine which is put inside the motor, hub of the wheel? No. That means the motor has better torque density and a power density than a IC engine. Whatever it used to be required to be this big for an IC engine, now it is this small. Okay? And that is with respect to motors and slightly on transmissions. Alright. The next topic is what is the next topic? Motor controls. Can you guys write what are the functions of a motor controller? What exactly a motor controller will do? What is the job of a motor controller? Anyone? Okay. Speed control. What else? Yes. Okay. The first one is correct. Anyone? What are the functions of a motor controller? Okay. Speed, regulation of speed. Okay. Do you mean the blue tag guys are first years? Sorry, green tag. Second year. Okay. Yep. Okay. Okay. What exactly the motor controller is doing? Okay. First and foremost thing, it is converting a DC to AC. Correct? So it is a converter or inverter? It is a inverter. So it is taking a DC, then it is converting to AC. One function. Sometimes it takes the AC and also converts to DC. So it is a bidirectional converter. Not all the motor controllers are a bidirectional converters, but many of them are a bidirectional converter. What do? They take the DC from the battery, they convert to three-phase sinusoidal AC, right? Then, when the motor is rotating, I told it becomes a generator, correct? What will happen? You will get the AC current, then you will convert that into a DC. Where do you supply to? You supply to battery. Okay? That is why when you are going down the hill, the battery gets charged. Correct? So DC to AC, AC to DC. So it is first function is converting a power. It's a bidirectional converter. DC to AC, AC to DC. What is the next thing? It also controls the, okay, let's start with it controls the speed. How does it controls the speed? Okay, let us draw a graph. Draw a graph in x-axis, sorry, in y-axis as speed. Okay, your y-axis is speed. The x-axis is time. Draw a graph starting at 0, increasing in speed. Okay, just a straight line like this. Tell me how the voltage input to the motor from the motor controller will look like. You have a 48-volt battery. You have a motor. I am running at 0 RPM. Then I am increasing the RPM to higher value. How will be the voltage of the voltage input to the motor? How will be the current input to the motor. V and A. V is a phase voltage, A is a phase current because it is a AC, right? Are we measuring a peak current or a RMS current? Two different things. But let us assume it is a peak voltage and a peak current. How it will be? You would have done this test as a part of your no load test for the motors. Yes? But forgot. Yeah. Speed. Which is speed? Which is voltage? Just write a straight line. For the speed, you take a straight line and draw a comparison of voltage to that. Just draw a straight line to the speed. Is there a relationship between voltage and the speed? Yes or no? Yes? Yeah. Then what is the relationship? We have partially discussed in the morning also. What is base speed? Why we cannot go above base speed? There is a flux weakening, right? But what is happening before that? If you have to rotate a motor from 0 RPM to 1000 RPM, how you supply the voltage to the motor? Would you supply constant voltage? Would you supply reducing voltage? Would you supply increasing voltage? Would you just change the voltage? Sorry? Reduce? Okay. I think somebody was checking V by F. Lot of things. What is that? All right. So, yep. Which one is now? It is. Yeah. Okay, one more question, then I'll show you the graphs. The same graph, how does the current will change? What will be the graph for the current? You have drawn the graph for the voltage, correct? What is the graph for the current? How does the current change with respect to the same test case? Again, this is a phase current which I am asking about. Too many questions in one day. I don't know, it is not like a super advanced gate questions. Alright? These are like fundamental machines. Anybody could draw? How does the motor current and voltage has a relationship? Okay, so can you see that? Wait. Can you see that? If the motor speed increases, the motor voltage will also? The motor voltage will also? Is that clear? What is the maximum voltage it was able to reach? It is able to reach? What is the voltage? 48 volt. I told you the motor will not go above the base speed if the flux weakening is 0. Correct? So once that motor reaches the maximum, then the motor speed will become constant, right? What is the relationship of motor speed and a motor voltage? Clear? Okay. How many of you got it correct? All right. So the next one. What is the, don't take the spikes, okay? If you just leave those spikes, just take the one linear line. What is the relationship between motor current and a motor speed in a no load condition? Right? This is in the no load condition. How I am conducting the test? I am increasing the speed of the motor. Correct? Every step by step I am increasing the speed of the motor. But until here, just take it only until here. The motor's current is almost same under the no load conditions. This is again under the no load conditions. Okay. So why did we go there? Why did we go to that topic? What we were discussing? Motor controller. In the motor controller, what we were discussing? Speed control. To showcase speed control, what motor is doing? That was the question. That's why we went there. When you want to control the speed, what is happening inside the motor controller? It is increasing the voltage. Correct? How is it increasing the voltage? Sorry? Okay, but how? With the help of what components it is increasing the voltage? Sorry? No. Yep. How? No. How do you vary the voltage? Okay. If you keep a MOSFET, the voltage will change. How do you switch it? Right? Then what input do you give to the gate driver? Yes. The way you give a PWM to the gate driver, you will be able to change the switching of the MOSFET, and that you will be able to control the voltage. Correct? How quickly you switch, you would have a rise and fall and rise and fall, so that way you would be able to control the voltage level of the output. Because your source is 48 volt. What you are giving to the motor is 3 volt, 4 volt, 5 volt, 6 volt, 7 volts, 8 volts, up to 48 volts. Who is doing that? The microcontroller is doing that. Right? Where is the input to the microcontroller? Throttle. And the feedback from the motor. Throttle and the feedback from the motor. Motor tells you what speed I am at. Throttle tells you how much speed I want. You will take a loop and then you will do a feedback controls. Right? Park transform, Clark transform, all of these things that happens to control the motors in place. So how about torque? If you want to change the torque, what do you supply? You supply current. right? So again, how do you current? How do you, because the AC current is a amplitude, right? You're changing the AC amplitude of the input. How do you do that? Again, a duty cycle, right? You vary the duty cycle, how long you want the pulse to be. If you let the pulse to be too long, so then current shoots up and falls back when you trip it down, right? You supply the current, you supply the voltage through the power electronics, so you will control the motor's speed and the motor's torque. Clear? What else you'll do? Direction control. How do you control the motor? In the engine, what do you do to control the direction? In your car, if you want to go reverse, what you will do? You'll put the reverse gear. In motors, do you have a reverse gear in the motor for the vehicles with the motors? In the electric car, is there a gearbox to go back? No. We just have to tell the motor controller to change the phase, the way the phase is rotating. Then automatically the motor will go reverse. So you don't need another reverse gear to take the vehicle back, right? What else you do? Mode control, like you have eco mode, sports mode, city mode, all of those modes, you can change all of those parameters. What else it can do? Hill hold assist, you want to go on the hill and you want to stay like this, correct? So you want to do a hill hold assist. Lot of these functionalities are done by a motor controller. Okay, so it has set of power electronics, it has set of microcontrollers which compute and take care of regulating the PWM. We discussed about the battery. It is set of cells, then chargers. I have one more slide, then we are done. What exactly the charger will do? What is the function of a charger? Sorry? Okay, that's all. If a question is asked in a GATE exam, write the block diagram of a charger. What do you write? Put a rectangular blocks, says AC to DC? No. What a charger do? That's all? Sorry? Okay, maybe to the charger's perspective, what exactly it will do? Okay, all right. So, all right. If you go to a charging station, right, you can charge Nexon car, you can also charge MG, you can charge Tesla, you can also charge Mercedes-Benz. All of them are different voltages. Not everything is at the same voltage, correct? Second thing, the input is AC, right? So first you are converting a AC to, behind that there are a lot of, first you stabilize those inputs, right? Because there is a lot of noises that is coming from the grid. You stabilize all of those inputs and feed it to your, you convert AC to DC directly. Okay, you will put a filter from the AC to the AC and then do what? Do rectification. Just think in the back of your mind, what else will do? So it depends upon what voltage do you want at last. Imagine the car is at 350 volt. Your input supply is 220 volt. What you will do first? Yes. First thing is to filter, do a AC transform, put a AC transformer, step it up from 220 to maybe 400. That's the first thing, right? Then you can take that 400, then make it to DC. That is a better approach than converting 220 into DC and then stepping up the DC, right? Because transformers are more cheaper and more easier to convert in AC to another AC at a higher voltage, correct? So that's why inside a charger, what is there? First boost, sorry, not boost, change the AC to higher voltage and then do the buck-up boost, whatever you want to do in the circuit operation. There are a lot of filters, regulators, controllers, everything will come into the picture, right? So that is what we do to do charging of the vehicle. When you studied the graph in the morning, can you all of you write what is the voltage graph for the cell? Lithium ion cell, we discussed. What was the voltage graph? How it was looking? Forgot? How was it? The graph is like this, right? Correct? When you charge the cell, will the voltage be constant? It is not like you will supply 350 volt constantly. Fundamental idea of physics is that the charge flows from higher to lower. To charge the battery, your supply should be higher, correct? So what is the functionality of a charger then? Regulating the DC voltage. You are first boosting, filtering, boosting, possibly again filtering, and then buck or boost, and then regulate. Because you don't want a constant voltage, you want a change in voltage. You also want possibly change in current in sometimes, because not all the cars are same, right? So all of these functions is done by this guy, charger. Okay. Nowadays, if you check in the internet, there is 1 megawatt charger. It is used for the cars. There's a company called BYD, which has megawatt charger. It means 1000 kilowatt charger. Imagine the power of the charger is 1000 kilowatts. That 1000 kilowatt is going inside the car. Have you ever imagined 1000 volt, 1000 watt, sorry, not 1000, 1 megawatt going into the vehicle? Yes, 1000 kilowatts going every second into the vehicle. How much of magnetic field is produced outside that? Inside the car, if you are there, you will die. But they have developed a technology in such a way nothing happens to you. Your mobile phones works fine, no EMI, EMC radiations, all of that. Right? 1 megawatt. I only heard thermal power stations and power stations talks at megawatt. But today we are talking a charging station running at 1 megawatt. Because what you want? Quick charge, fast charge. 10 minutes charging, I want to go like 500 kilometers. Then how do you do? Sir? Say the pack itself is at 1200 volts. The vehicle itself is at 1200 volts. Yes. Yes. So if you want to go for a 1000 kilowatts, if your vehicle voltage is 1000 watt, how much current you are supplying? So it is 1000 kilowatt means 10,000, 1 lakh, 1 lakh watts. 1 lakh watt divided by 1000 volts. That is 1000 amps. You're supplying 1000 amps every second through the cables. That's how much power is going through those cables today in terms of the charging stations. Imagine they should have a one substation just to supply 1 megawatt. And that is just a transformation what is happening with respect to charging systems in place. So if you install that charging station in BPTU, the whole power will go off, because you will not be drawing 1 megawatt every second here. Not even the whole college is, I think, rated for 1 megawatt. So with that, just think, to handle 1 megawatt, what should be the size of the cable, what should be the size of the gun, how much the cable will get hot. It's unimaginable. Okay, then we have a lot of other things: battery cooling, battery heating, motor cooling, motor heating, all of these things. So with that note, I say a second thank you. So to give another opportunity to speak for 1 more hour, I wish it was useful for all of you guys, and thank you very much. All the best.
Hello. So with extreme sorry, I am announcing, like other speaker, Dr. Ranjan Kumar Behra, who is traveling from Patna to here, supposed to reach here at 10:30 morning. So every half an hour I am checking, his train is getting late by half an hour, half an hour, half an hour. Now it is showing 6 o'clock. So his return ticket is at 8 o'clock. So I do not know whether he can return today or not. So that is the ground realities. We are very sorry. So we thought maybe 1 hour, 2 hour, 3 hour the train will be late. But 7 hours, 8 hours late, it is our bad luck. So I will request him. So I was thinking actually he will reach here by 5 o'clock, so that we'll do the certificate distributions, then some snacks, then maybe followed by 6 to 7 his talk, so that he can return back by 8 o'clock. But now it is showing 6 o'clock. So definitely it will be 7 o'clock, what I believe, because every half an hour I am checking, it is increasing another half an hour. So that is the today's reality. It is an experience for us also, like how to make the travel plan for speakers who is traveling in this particular route, Tata and Rourkela route. So we'll do one thing, we'll proceed with valedictory and certificate distribution, followed by high tea. Then we'll see, depending upon your mood and his train, if it is suddenly changed, we'll see whether we can have a half an hour session at least after the tea break. Otherwise, I will request him to have a webinar, maybe this week, sometimes on Thursday, on Friday, because your Monday, Tuesday, Wednesday, you have internal exams. So before you go on your puja vacations, either Thursday or Friday, depending upon his availability and your availability, we'll see. We'll keep a webinar type, so that online he will be with us and we'll try to connect and do the things. So once again, We are very sorry. So your cooperation is needed to make it in the online mode, rest of the things. So now I will hand over the mic to your expert. So you take over and do the certificate distribution function.
Thank you, Suraj sir, for the enlightening talk. We now move to the certificate distribution ceremony and group photo. I request all our dignitary academic guests, director in charge, HOD of Electrical Engineering and convener to kindly join us for the distribution. Sir, please. We request all the students to kindly come forward when their names are announced and receive their certificate. I repeat, we request all the students to kindly come forward when their names are announced and receive their certificates. The sequence will be first 4th year, then 3rd year, then 2nd year, then 1st year.
अर्धेंदु शेखर प्रधान, आयुष भुइया. Give a big round of applause for them, guys. आयुष भुइया, आयुष्मान बेहरा, संदीप साहू, स्वर्णभ स्वाई, ओम प्रकाश साहू, स्वर्णभ स्वाई, संदीप साहू, ओम प्रकाश साहू, भानुप्रकाश महांती, समीर कुमार बेहरा, दिव्य प्रसाद साहू, राकेश कुमार बेहरा, गायत्री घोष. Give a big round of applause for them, guys. Appreciate them. गायत्री घोष, राम्य कुमार महांतो, विक्की प्रधान, रश्मि रेखा राउतराय, सारिक अनवर, त्रिलोचन माझी, अनिकेत महांती, दयानिधि महांतो, सच्चिदानंद बेहरा, प्रगति मेहर, मोहम्मद फैजान, विष्णु यादव, रोहनलाल दास, दुर्गा प्रसाद बारिक, हर्षा दानी, सत्यजीत बिस्वाल, आकाश पसायत, स्वप्न सरिता महांत, सुवर्धन जालो, सुवर्धन जालजो, सालको, विभूति भूषण महांत, प्रयास कुमार साहू, मानस रंजन माटियारी, लक्ष्मी नारायण सुबुधी, लक्ष्मी नारायण सुबुधी and Rashmi Prakash Nayak. Guys, please appreciate them and applaud them with claps. Now it's time for MTech second year, Shrivatosh Urma and Sunil Kindo.
Now it's time for the third year students. Ashutosh Parida, Swayam Sarthak Mahakud, Ashutosh Parida, Swayam Sarthak Mahakud, Abhiram Mohanty, आशुतोष परिडा, स्वयं सार्थक महाकुद, अभिराम मोहंती, विश्वजीत साहू, पी ओम प्रसाद महुरिया, विश्वजीत साहू, विद्याश्री नंद, अनुभव पात्र, ज्ञानरंजन त्रिपाठी, ध्रुव कुमार, अभिजीत कर्माकर,
Please welcome them with a great round of applause, guys. Everybody.
वासुदेव पंडा, वासुदेव पंडा, संजना मिश्रा, पपुन कुमार बेहरा,
Everybody, please welcome them with great round of applause.
शोभाराणी महापात्र, द्विजेश मधुल, मनुराज महातो, संग्राम राउत, आशीर्वाद पृष्टि, ओम प्रकाश साहू, सिक्का विकास, सुप्रभात कौर, बिल्टू मंडल, सुप्रभात कौर, बिल्टू मंडल, अंचला कुंभार, अश्मिता कुमारी, भवानी शंकर बेहरा, खिलेश कुमार निषाद, निशांत कुमार सेठी, निशांत कुमार सेठी, Akash Nath, Ashish Anshuman, Divya Jyoti Mahalya, Biswajit Senapati. Biswajit Senapati. Everybody need to enter from this side and they will exit from that side. I repeat, everybody need to enter from this side and they will exit from that side. Biswajit Senapati, Sangam Priyadarshikar, Subhajit Palta Singh, Saubhagya Sahu, Subham Sahu, Swayam Sarthak Patnaik.
Guys, show some energy and applaud for them, please.
Prayas Das, Subhajit Rana, Subhajit Rana, Rohan Majhi, Rohan Majhi. Now it's time for the second year.
Now it's time for the second year. Prashika Mahapatra, Priyansi Pradhan, Suryakant Sahu, Asit Kumar Pradhan. Please everybody clap for them. चंद्रिका गड़ात्य, वेद प्रकाश पुरुषेत, स्नेहा सुहांगी मलिक, दिव्यज्योति परिड़ा, संदीप कुमार साहू. Please everybody clap for them. अभिषेक राउत, सयंतिनी सतपथी, भरत सामल, आयुष रंजन पात्र, तन्मय सेठी, सुरंजन मंडल. विश्वविजयी जगदेव, प्राची प्रधान, भवानी शंकर प्रधान, मानसी साहू, शिवलक्ष्मी महांती, सिद्धांत बरल। Everybody is requested to take their certificates. If they are found any technical issues, technical team is there to resolve that. Satyanarayan Raut, Sunanda Behera, Dibyaranjan Naik, Pappu Rohidas, Mukesh Kumar Patra, Subham Singh, Sakti Prasad Raut, Anshuman Rana. अभिलाष राउत, सोनाली चौधरी, हरे कृष्ण साहू, एसके फरहान इस्लाम, अनिशा बनर्जी, शुभम साहू, आदित्य नारायण चौधरी, बद्री नारायण बाग, प्रियंका साहू, मल्लवी मनस्मिता साहू। देव कुमार सुना, अविनाश बेहरा, ज्ञानरंजन परिडा, शुभंकर पंडा, प्रॉमिस महापात्र, सुमित बेसन, कृष्णचंद्र रथ।
Finally, it's time for our first year students. Jatin Kumar Mahato, Dinesh Kumar Shihal, Swastik Satpati, Snigdha Mahapatra. Subhranshu Sekhar Raut, Devashish Kumar Sharma, Mohit Kumar Mahapatra, Manashwini Das, Subham Nahak, Ravindra Kumar Sahu, Surya Kanta Pradhan, Soumya Sitanchu Malik, Samarpita Sahu, Saubhagya Ranjan Sahu, Namo Narayan Sethi, Prithviraj Behera, Ankit Kumar Nath, Pradosh Kumar Raut, Jogesh Chandra Munda, Prayagraj Mahapatra, Archita Das, Piyush Kumar Panda, Satyaprakash Swain, Swayam Shri Hota, Audience seems to be very dull. Kajal Padhi, Durga Prasad Patnaik, Jyoti Mahi Maharana, Kirti Raj Raut, Piyush Pratipanna Bindhani, Alawa Behera, Manish Shamal. I request audience. Manish Shamal, Swayam Saurav Ray, Amarjit Sahu, Devansh Swain, Subham Bisoi, Sapan Panigrahi, Adya Abhishek Mohanty, Alok Kumar Jena, स्वस्तिक कर, ओम प्रकाश साहू, स्वस्तिक कर, ओम प्रकाश साहू, दिव्या जीवन साहू, अभिनाश नाथ, चुन्नीलाल नाइक, रामचंद्र हंसदा. I repeat, Ramchandra Hasda. Now we will have a group photo year-wise. So the same sequence will be followed: 4th year, 3rd year, 2nd year, 1st year. I request everyone to be on the stage. 4th year. 4th year, I request everyone to be on the stage for the group photo. हाँ, 4th year and MTech 2nd year can join. I repeat, 4th year to please come to the stage. Come with your certificate. Yes, come with your certificate. I request everyone to come with your certificate for the group photo. 4th year. Yes, everyone maintain silence. Now, I request 3rd year students to please occupy the stage. I request every 3rd year students to please occupy the stage. Yes, please remember, you need to enter from this side and you have to exit from that side. Students, please remember, you need to enter from this side, you need to exit from that side. Now, I request all the second year to occupy the stage. I repeat, I request all the second year to occupy the stage. I request everyone not to leave the auditorium. Snacks has been arranged, so don't leave the auditorium. Now, I request all the first year to occupy the stage. I request all the first year to occupy the stage. Students, please remain here only, don't go outside. Snacks has been arranged, so please remain here. As some students were missing, I again call all the fourth year students to assemble in the stage for a group photo. I request all the fourth year students to be in the stage for the group photo. I repeat, I request all the fourth year students to please be on the stage for the group photo. Sir, sir, I request you all to please be in the stage. We need only your photo, no student. Sir, I request you all to be in there, please, for your photos. I request all the volunteers to occupy the stage. I also request all the volunteers to occupy the stage. I request all the volunteers to occupy the stage. I request all the volunteers to occupy the stage. And everyone, please be seated, please. Thank you, sir. With that, we conclude the seminar on the emerging trends in electric vehicle technology. We invite you all to join for high tea. Thank you all for being the part of the seminar. We wish you a great evening ahead. See you again with more innovations and milestones.